Hello everyone. In this tutorial, I want to show you how to simulate casting process in Thirdcast software. But before starting the simulation, I want to explain a little bit about why we need simulation in our project. Then I will explain the main steps to simulate a casting process in any software. And then I'll introduce you Thirdcast software and how you can have access to that. So why simulation? And generally speaking, there are three approaches when doing a research. You can do analytical research, experimental one, or numerical one. In analytical research, you are dealing with the theoretical formula or developing them or developing them or extending them to have a more accurate result, right? For example, here these are three formula which are showing how to calculate the efficient height of sprue based on the type of gating system. The experimental one, for example, you design a test and do casting. Then you will cut a sample from the casting product and check the microstructure. Or we can check the cooling curve or residual stress, whatever that you are interested in, right? If the results were not satisfactory, you have to change some of the parameters in your casting process and then do the casting again and check the results to see if desirable or not, right? So imagine the casting geometry is very complex and there are many parameters that can be changed and it's not under your control. So how many experiments do you want to do? So in these cases, it's so difficult to have an efficient design without simulation. So here the numerical methods are very useful. You can simulate the casting process for a complex geometry and see the effect of changing different parameters on the final products. For example, stress distribution or microporosity or cooling curve and anything that you are interested in. So I'm going to show you a very simple case example about the advantage of simulation. In this casting, you can see that in this casting, we are interested in residual stress, the amount of residual stress at the middle of these arms, right? So residual stress are the stress which are remaining in the structure after casting, and they will they might cause crack or deformation in service condition, and it's really important to get rid of them. And to get rid of the residual stress, we do different heat treatment for any kind of casting, and so we release the residual stress. But the first step is knowing how much residual stress is in there. So we do the simulation first. We do the simulation and we find the residual stress distribution at the points that we are interested in, right? Then we do a casting. I mean, cast the part because the part was very simple, and do the experimental test to see the residual stress distribution at the point of interest. So we did the simulation, we have the experimental result as well, right? Now we compare them. If the simulation results were quite the same with the experimental one, we can say that we validate our result and we can use this simulation for future heat treatment to find the best parameters for heat treatment, right? But if it wasn't good, I mean, it was kind of conflicting, then you have to improve your simulation and try to validate that first. So this is the story of using simulation and experimental works and tests in a project. So if you convinced, now I want to show you the basic steps that you have to do in any kind of FEM software. You first need to import the geometry, and in that you have to consider any symmetry plane, because symmetry condition can save the time considerably. Then we have to mesh the part. So by meshing, I mean you have to discretize the geometry, because the base of finite element method is on discretizing the geometry and solving the partial differential equation for each element, and with their specific methods, they combine the result and give us the final result in terms of whatever that we are interested in. For example, residual stress distribution, pooling curve, or anything. So the third step is defining initial and boundary condition, because in any partial differential equation that we want to solve, we have to define the boundary condition and initial condition. And FEM software are based on those equations. So we have to define initial and boundary condition in our model. So for example, here the symmetry boundary condition is applied for this casting. And also, for example, in one part, we show that the initial temperature of the casting was, for example, 740 degrees C. After that, we run our simulation, and running will take like 1 hour or a week based on the complexity of your model, based off the number of elements or meshing. But once the simulation was completed, then you can do analysis on that. And this step of analysis is post-processing. Okay, so now I want to introduce Thirdcast software to you that you're going to use it in this tutorial. So Thirdcast is a commercial FEM software that is used for simulation of different casting and forming processes. And there is one main difference between Thirdcast and academic software like ANSYS. In ANSYS, because it's more based on academic, you will know the theory of every single thing that you are working with, right? So it's very sophisticated software, and it has a comprehensive manual that you can go through every single theory that you want to do, but that you are dealing with in your simulation. But Thirdcast is mostly used in industry because they want to have an idea about what's going on if they want to use different parameters, what's going on in the casting. So they don't need to know every single thing about that, but they are more result oriented. So Thirdcast is kind of software that is very useful in industry. And we find it very useful even here to introduce the concept of FEM modeling in casting for you. So to have access to Thirdcast, you can check this link. So this link got 2 digits. So these 2 digits are showing the computer number. There are about 10 computers available for you to do the simulation, and their number is starting from 63 to 71 or 72. So you click on this link, and then you change this number to, for example, 64, then you will connect to the third computer, or change it to 65, you will connect it to the fourth computer, and so on. And also, when you click on that link, it asks you about your username and password. So your username will be your cwl.stu, and your password will be your CWA password. So one more thing that I wanted to tell you is that when you connect to this page, if you see power on status, it means that somebody is using these computers in the lab. If you see in use, it means that somebody is using the computers online. So try to connect to the computers which are available, right? And also, when you do your simulation, you will run your simulation and might leave the computer for 2 or 3 hours, right? In this time, this computer will be in use for you. So make sure that you know the number of computer that you did your simulation. That is important. So that's it about the introduction.